All right, so let me just quickly apologize that I'll be sitting down today, because I had a knee surgery like a week ago, so I'm really glad I can be here at all. But I wouldn't be able to stand up, so I'll be sitting. Anyway, I will be talking about Swagger, and two things should be obvious right from the start. The first thing is that I really wanted to use the word mere in a title of something. And the second, that it will be about REST interfaces. I suppose you know that. Quick show of hands, who knows what Swagger is? OK, almost all of you. And who uses Swagger in their projects? So again, like a half of you at least. OK, and different set of questions. Who thinks that commenting your code and documenting your code and interfaces and so on is really important? OK, and who enjoys doing that? Thought so. OK, so let me start. Just a quick step sideways. 2 years ago, I saw a presentation about Kotlin, and Hadi Hariri characterized Kotlin that it's kind of like JavaScript, but in a good way. And I liked it so much that I will be using it today. And I will tell you that Swagger is kind of like WSDL, but in a good way. And I will let this sink for a while, so that people who are frightened just by seeing WSDL on a slide can, leave for an early lunch. No one? OK, good. So the big question is whether we should document our REST interfaces. And most of you agree with me that we definitely should. The question is how. Years ago, when I first heard about REST, when it all started, I asked some people who were early adopters and who were already using REST, how are their REST interfaces specified, how it is documented that it lives at a certain URL, it takes some parameters, it returns something. What are the attribute names, and how the user that wants to consume this interface, how will they know? And the answer is, well, REST is so simple that we don't need any specific tooling. We will just tell each other. The front-end developer will ask the back-end developer how the service looks like, and the back-end developer will tell them. So I thought, OK, let's see what happens. We are in 2019, so we know that this is not the way to go. As your application grows more complicated, you need to document that interface somewhere. You can't just let people talk to each other. I mean, they should talk to each other, but it shouldn't be the definition of the interface. So what else can you do? Well, you can sit down and write a document. If you were here last year, you may remember I was talking about check standard for open banking, which is a 400-page long PDF defining the interfaces. Most pages look like this. I mean, it's all there. You see the attributes. You see their data types, sort of. You see some kind of description. Is it ideal? I would say no. So, but I see it in different projects that that the interfaces are sometimes described just by writing a free text document, something like that. It's better than nothing. By the way, good news is that I heard, I didn't check, that this check standard for open banking is now in Swagger as well. They did it during the last year, so I hope it's true. I just heard that. Yeah. So if we don't want to use just a Word document or PDF document, what can we use? Well, luckily, we got Swagger, right? So what is Swagger, actually? It's a very simple domain-specific language for documenting REST APIs, obviously. You describe your URLs, you describe your HTTP methods, you describe all your parameters, headers, request bodies, response statuses, what happens when and how. Usually in YAML, or at least I recommend using YAML for working with Swagger. You can also use JSON, but I think that for writing it manually, YAML is a better format. What are the advantages of using Swagger over, for example, long PDF documents? Well, the biggest advantage, obviously, is that it's machine readable, and I will show you what can you do with that later. It's also comprehensible to developers. I mean, if you have a developer on your team who wouldn't be able to learn Swagger, sorry, just fire them, I guess, and maybe hire me, or I don't know. Anyway, it's also understandable by most analysts. The more senior analysts they are, the better they will understand that. But this is also important because if you are creating a complicated enough application, then the business aspects will start showing in the interfaces. And it's important that the analysts who understand the business understand at least a bit your REST interfaces, and that they can tell you that you are missing something in the, in the request or in the response. And another big advantage of Swagger, it's a boring old plain text, which means you can put it in under your version control, and you can see who changed what, when, and if they provide a good commit message, which they won't, but anyway, you may even find out why. And this is something you probably cannot do with PDFs, Word documents. I've seen using, for example, Enterprise Architect to model REST interfaces. Again, it's a nice tool, but have you ever tried to compare two different diagrams of Enterprise Architect? It's not really easy. So, okay, let's just say we've decided to use Swagger. How can we use Swagger? There are two possible approaches. You can see that I'm ever so slightly biased towards design first. I think you should do it. You should start writing your Swagger file by hand, consult it with all interested parties, and only then give it to developers and tell them, okay, you create the interface, you create the front end that consumes it. I mean, the developers can be involved in creating the design, obviously. Then they are one of those stakeholders, but not necessarily all of them. So how can you start with Swagger if you've never seen it? I highly recommend this online editor, editor.swagger.io. I have it here somewhere. Yes. This is my example Swagger that I will be using today. It has just one entity, student, and I will be, getting a list of students and creating new student and updating students. You know the deal. And this is how Swagger looks like. It's quite understandable, I think. So here I say that, okay, I have /students, and with HTTP method get, I get a list of students, obviously. And if I use post, then I create a new student. And then I also have /student ID. Again, get gets one of those students by their ID. Put saves a student, and delete deletes a student. The advantage of this online editor is that if you are starting, it has autocomplete, and it tells you pretty much what to do. So if I want to add delete to /students. It creates the template that I just need to fill in. And also, as you can see online, it will tell me that I have some errors there. So let me just delete it back so it's error-free. And everything you create, you can see on the right side, you can click on it and see, OK, so I can get all students, and they are sorted by something. And I can see that I will receive a list of students. And what is one student? Well, it has an ID, first name, last name, year, and those 3 attributes are required. Year is from 1 to 7, because as you will see later, all my students go to Hogwarts. And we can delete a student, we can save a student, and so on. So this is a nice tool if you are starting with Swagger and don't really know all the stuff yet. On the other hand, as your Swagger file grows larger, the editor gets really slow. So what I usually do, I just take any other editor that allows me at least basic syntax highlighting of YAML files. I write it just from my memory, and then I copy it here just to see what errors I've made. I fix the errors and go back to my favorite editor, whatever it is. OK. So this is my REST API that I will be using, pretty much working with students. Let me go back to presentation. So we've got Swagger. We've got a formal definition of our interfaces. So that's good. But from your own experience, because many of you are already using Swagger, let me ask you, has this ever happened to you? Front-end developer used /student instead of /students when asking server for the data. Or first name with lowercase n when capital N was expected. This is, by the way, a problem that we've been having on my current project for like 3 weeks. And it kept repeating. We fixed it, and a week later, again, first name with lowercase n. I don't know how it happened, how it got there. It was there again. And it took us like 5 times before we hopefully got rid of that. I still expect that it will appear somewhere, but I don't know. If you are Czech natives, you may have problems with words like width, height, or length, right? Again, also popular mistake, IDs. Are they strings? Are they numbers? Does server care or does it not care? So if you know this, you may be asking, just like Joey, there's got to be a better way, right? Of course there is. And the better way is called Swagger CodeGen, which is another tool from swagger.io. And I will talk about it in a second. But before I get to that, what does it actually mean to implement a REST API and to consume a REST API? So if you are creating the server implementation based on your language of choice, it will look probably differently, but you will have to do something like this. You will have to do some kind of request mapping. So you will have to describe that this URL with this HTTP method should invoke your method in your language. I will be using Java examples, so in my case, it will be Java method. And you have to describe that some URL parameters or path variables should be translated to regular parameters of my Java methods. And if you are using typed languages, such as Java, you also have to create data transfer objects, which are data structures containing the request-response bodies, and so on. So in Java, using Spring, it may look something like this. I create a student controller, and I create 2 methods, one for getting student, one for updating students. As you can see, those methods don't do anything right now. But all of this has to be there, and I must not make a mistake, because if I do, it will stop working, or it will be on a different address, or if I, forget to put this valid here, it will actually work, but it will not validate the input data, which I probably want Spring to do for me. Same goes for the student DTO. Again, if I forget this not null here, well, then first name won't be required, and I want it to be required, right? And similarly, on the client side, what you need to do, you usually create some kind of service that has functions in JavaScript, right? Functions, again, corresponding to different REST operations. And again, you have to translate this to specific URLs, specific URL parameters, path variables, and object structures need to be translated to request response bodies. And usually you return some kind of promise or something, again, depending on how you deal with asynchronous calls. And all of this is extremely boring to write. I don't think anyone enjoys that. And it's very error-prone, as you, again, probably have your own experience, or at least in my experience, there are a lot of unnecessary mistakes. And by the way, if we do this, that we have Swagger, we have a Java implementation on the server, and we have a JavaScript consumer implementation on the client side, then we've actually described the same thing 3 times, once in YAML, once in Java, and once in JavaScript. Why? Why should we do this? So the answer is Swagger CodeGen. That's a command line tool that allows you to generate code from your Swagger specification. As you can see, it covers quite a lot of languages. I hope that you can find your favorite language there. If not, well, I can't really do much about that, but I hope you will. And what that means? Well, it means that your backend developers don't really have to care about REST APIs, or maybe not all of them, because they care about the business logic of the application. That's what they are paid to do. And we will just somehow expose it as REST, but they don't have to write those REST controllers and those DTOs. It also means that if you have legacy code and you want to expose some functionality of that code as via REST API, you can easily do that, because Swagger CodeGen will generate all DTOs and all controller skeletons containing pretty much empty methods, but with all the correct request mapping and all the Java annotation and so on. And you just, quote unquote, just provide the implementation. But if you have already, an existing business logic, you just invoke that business logic from the controller. On the client side, again, the CodeGen will generate DTOs, which is interesting, at least if you are using TypeScript. And it will create that service with functions for fetching data. So again, your front-end developers don't have to deal with the network communication. They don't have to think about whether they put the right URL in or not. They will just call a function that has been generated for them. And you can also use this for mocking, because if you create your server skeleton and put just some mock data into that and run it, then your front-end developers can use this server as a mock server, but it's the real server. It just contains fake data, but it's really the server that they will be using in the end when it's all completed. Currently, again, from my experience, front-end developers, don't want to or even can't wait for back-end developers to finish their job. So they create their own mocks, sometimes very sophisticated mocks. I'm always amazed what they can do. That's cool. But sometimes the mocks aren't actually don't have the same structure as the real server because you just made a mistake when you were creating the mocks. This can get rid of these errors because you have the real server, just fake data. Okay, so now for the fun part when everything will go horribly wrong. Let's try it. So I've got some demo application that I will be, building with you. Not all of that application, but some parts I will be building here. So let's just say that I really have an existing business logic in Java. So I've got my student class that is connected to database. If you know Java and Hibernate, then you know what these annotations mean. If not, it doesn't really matter. So I've got a student, and I've got a student service which provides methods to get all students from the database sorted by something, get a single student, save a student, which can either create a new one or update an existing one, and delete a student. And then I've got some simple configuration that just says that I'm using an in-memory database called H2, and that I populated with some initial data, 1, 2, 3, 4, 5, 6, 7 students. And that's pretty much all of that. So I've got a functioning web application in Java. It just doesn't expose any REST APIs. I can start it, it will run, and it will be pretty much all it does. It runs and consumes memory, but nothing really useful. But here you can see that it really creates the table student, and what you cannot see here, but it populates it with data, and it runs. So let me just stop it, because now it's not really useful. So I've got my business logic, right? Hopefully it works. Hopefully I've got unit tests. I don't, but I should. So that unit tests, or maybe even integration tests, could show that the business logic is OK. So let me just quickly switch branches to step 2. And in step 2, I've added a simple front-end application. And I have to say one thing, disclaimer. I'm not a front-end developer. So A, the application will be ugly. And B, the code will be ugly as well, probably. So please excuse me. It's written in React. And I'm pretty sure it breaks all best practices that React developers should do. I've tried my best. I'm not sure if I should have said that this is my best, but anyway. And also, this is my first attempt ever to use TypeScript. I've never used it. I wanted to, so I tried it, and I've encountered some weird errors, which maybe you would be able to solve. I didn't always. So sometimes there are some weird things, especially in IDEA. The application works, but IDEA is showing me some errors. Anyway, we should be able to start the application so that we can look at it. So we are on start. Yeah, OK. Yeah, so I've got some students. It's not connected to the server yet, right? So I've got some students, and I can click on a student. I see a detail/edit form for that student, and I can, I don't know, say that Potter has gone a year up and save it, and yeah, it seems to work. I can even click on delete, but I didn't actually program the delete functionality, so it does something, but it's not visible. So let me just quickly, again, show you some parts of the code. So I have pretty much, yeah, here. No, excuse me, here. So this is the list page. where I use React hooks, again, first time for me, to get students. Then I put it into table. Here you can see what happens if I click on delete. It calls some kind of students API and deletes that student. Similarly here, we actually get all those students and put it into the state of the application, state of the component. And then I have a student component, which is the detail/edit. And again, I get a particular student by his or her ID. And here I'm dealing with changes in the form and update the student. And this is pretty much everything. Yeah, and if I click save, then I will call put student. So this is my front-end application. It's working. The only thing is that this is my API. I just have a list of 3 students. And this is those get student, put student, and delete student methods. I just quickly return promise resolving to something. And this is where you can see that by deleting, I don't actually do anything. So that's why I didn't really delete a student. Because I'm using TypeScript, so here we've got the definition of a single student. So now I've got a business logic that doesn't expose any REST API and a front-end application that doesn't consume any REST API. So we should fix that, right? So step 3, I add my Swagger file. This is why we are here. So this is the Swagger that you've already seen. And here I run Swagger code gen with several arguments. I won't bore you with the details, but it will generate those classes and I copy them somewhere. So let's try it. This is for the server side. Yeah, but I have to go to here. Oops. No, excuse me. Source Swagger. Right. So let's just generate those classes. You can see that something happened. Some classes were generated. And they should appear somewhere here. OK, so under this REST API, I've got my student DTO generated by Swagger CodeGen. And I've got my controller mapping for Java. Here you can see, for example, that request mapping for /student API student ID for delete invokes a method. So now I just have to implement it. So let's create some implementation. Oops, controller dot student controller. And let's just say that it's REST controller. And I will be using that student service, which is my business logic. And, oops, not. Of course, I have to say that it extends student API. Or students API. Typo. Extends students API. OK, better. And OK, so let's just start with what? Getting one student by their ID, right? So student is student service get student ID. So that's the easy part. As you can see, I don't have to really think about the request mapping about that, that I get this student ID correctly as a path variable, it should just work out of the box. The only thing I have to do is to convert actually my internal implementation of student, which is this, into, excuse me, different student DTO, into, just a second, into this, generated by Swagger. So in order to do that, I could do it in the controller, but let me just create a specific converter for that. So let's just say converter.student converter, and let's just say that it's Spring component, and that it contains a method that returns student DTO. It's called toDTO, for example, and takes a student as a parameter. Again, typo. And all I have to do is returns new student DTO, and I have to copy ID from the student, and I have to copy first name, and I have to copy last name, and year. That should be it. By the way, in a real application, I would again use some kind of tooling for these converters, but that would be too much Java specific, so I didn't want to do that. Okay, so I've got student controller. I will also use student converter. And let's just create a constructor. And now all I need to do is something like return response entity OK, because I want an OK status. Student converter to DTO student. And excuse me. So now I should have my get all students REST API. It's quite straightforward because I have already an existing business logic for, get one student, for getting one student. So in the same way, we can quickly implement all those other methods. So for example, okay, let's continue with what? Delete a student. That should be easy. Student service, delete student ID, and I only need to return a new response and response entity with HTTP status no content, because I didn't show it in the Swagger file, but if we look at it, I'm saying that if I delete a student, my response is supposed to be 204. So I can delete students. What else? Get all students. OK. I will have to improve my converter so that it is able to convert list of students to list of student DTOs. So public list student DTO get to DTO, for example, list of students. So many typos today. And I just map all students by using already existing toDTO operation and collect this as list. If you don't know this feature of Java, it just goes through the whole list and maps every student into student DTO and collects it as a list. And later I will also need the corresponding conversion in the other direction. So I will need something that returns a student from DTO, and it will be something like this. Set first name, get first name, set last name, get last name, and set year, get year. Okay, that should be all. And yeah, I should return the result. Okay, so back to the converter. Now I want to get all students, so that should be quite easy now. Return response entity.ok, student converter to DTO, student service, get all students. Okay, that should be all. And what's missing? Post student and put student. Okay. So student is student converter from DTO. And now I will save it. Student service, save student, and I should return the ID assigned to this new student. So return response entity.ok, student get ID. I think that should be all. And last but not least, put student. And again, quite simple. I can actually copy this line. No, yeah. Then I will assign this ID because I need to get the student ID from the URL. That's a path variable, right? Student ID. And I just save that. Save student, and return no content. And unless I made a mistake, which is of course possible, now I have all those REST operations that I promised in my Swagger, and this is all I had to do, provided that I've already had the business logic. So I pretty much, in a straightforward way, call the business logic and return the result, and I don't really care about the REST API mapping. So let me just check that it works. I will start the application, and because I also used some additional Spring configuration magic, I should see now, yes. Host 8080, oh, this is what I'm, yeah. This is actually something called Swagger UI. It's generated in runtime from my running application, and again, I can see, yes, my application provides all of these interfaces, and for example, students, again, I can see how it is defined, but I can see, I can also try it. So let me check. Yes, it works. It returned all those students as a JSON. So my server is pretty much done. And so let me show you what Swagger CodeGen can do for you on the client side. So let me just quickly commit whatever it is. And switch to step 4. I can actually let the application run. And I will switch to the client side. No, not yet, sorry. If I go back to generate classes, I added to this shell script one more invocation of Swagger code gen, this time for TypeScript. And again, I will copy those TypeScript classes into my client application. So let me run it again. All right. So here are the TypeScript files generated by Swagger code gen. There are just some glitches that I wasn't able to fix. Somehow I have to create this and put, excuse me, this into that. I'm not sure if it's a bug in the generator or my, not good enough knowledge of TypeScript. And the same goes for this, because I think it expects a different version of TypeScript than I'm using. So I have to do 2 small changes here and here. Now it should work. It's, of course, painful to change, generated files, but I really hope that this is something that's fixable and that it's just, caused by my lack of knowledge of TypeScript. So let me just pretend that this never happened, that those files were generated correctly right from the start. And all I have to do this is to, create a real students API. So let me delete this, and let me actually delete also all of this, and just say new default API, new configuration empty, and all I need to do here is to say that my server runs at HTTP localhost 8080. Now I can remove this import, and if I go into my components, I will just change my student DTO import from this to REST API/API, hopefully, no. Okay, let me do it a different way. Yeah, here. Okay, so it's supposed to be like this. And the same goes for student component. Now I should be able to delete my, my original student DTO written by hand. It seems to be working. And so let's, it's still running, but I will restart it. And let's see what happened. Yes, so I've got my students, served by the server. Now I can even delete one of them. It should work, yes. And again, I should be able to modify a student, save it, and it works. So all I had to do was actually change, well, pretty much write this one line. That's all I had to do on the front-end side, and change imports, which is not really, really a big deal. So I'm almost finished. Let me just again commit that, so I can switch to the last thing, because the only thing that I don't like about my solution, if I go back to the to the server side, is that I have these generated classes here, that student DTO and students API, because should I put it into my, under version control? Should I commit it into Git? If so, then I duplicate my information, because the source information is in the YAML file, and these are just some, byproducts. But if I don't put them into Git, then whoever clones the repository needs to first run the Swagger code gen, and only then the thing compiles. And if you have a continuous integration server, you have to do that there as well. Luckily, Swagger CodeGen contains a plugin for Maven. For those of you who don't know Java, Maven is a build tool for Java, one of the most popular. And so what I can do is to create a new Maven module for Java that contains only the Swagger file and put my Swagger CodeGen here. This is the definition of what should be generated and how it should be generated and where it should be put. And now if I compile the project, no, sorry. Yeah. This is how Maven works, for those of you who don't know it. Then you can see somewhere here that during compile time, during build time, the classes were generated. And hopefully now I should be able to get rid of this, as if it never happened. And my application, which is still running, so let me stop it, should run again even without that, because it now uses generated classes. Oops, so no. There's a problem. Why? The class is here. Okay. Let me just build the project again. That's weird. I swear it worked today in the morning. Okay, so something went wrong. Doesn't matter. I will just delete all of that and switch to the branch where it should work, hopefully. Yeah, I know what I forgot. What I forgot to do, I will just show you. Here, I forgot to say this, that my server application actually depends on that new module that contains those generated classes. This is why it didn't compile. But now it does, or at least it should. And if I start it, it should work as before. Let me just quickly check it. OK, so everything is running. So now I don't even have those generated classes. They get generated during each build, which is pretty much what I wanted to do. Probably you could do similar thing on the front-end side, but my knowledge of NPM is not good enough to do that. But I think it should be able to work in a similar manner. So again, you don't have to have those generated files under your version control. So that's almost all of that. Just one last note. You may have heard about Open API, what it is. Swagger, the last version of Swagger is version 2. And when they created version 3, they renamed it to Open API version 3. And there are also 2 versions of Swagger CodeGen. Version 2, of course, can handle only Swagger version 2. Version 3 of the CodeGen can handle both Swagger version 2 or Open API version 3, but they dropped several languages. I don't know why, but the set of languages that they support is not as large. OK, so thank you for your attention. And we've got a booth upstairs, Unicorn booth. So come check it out. We've got some prizes for you if you enter our competition. The sources for all those examples are on my GitHub account, and that's really all. Thank you.
OK, Okay, thank you, Ondra. Let's see if we have some questions. Okay, a lot of questions.
Okay, so I think we can skip the first question.
Okay.
Because I've already answered that.
What about incremental changes in the API and the code gen? Is it stable?
I'm not sure I understand it correctly. In my experience, the code gen is quite stable. We've used it in several projects, and I was glad that we did. But I don't see the connection between incremental changes in the API and stability of the code gen. So maybe come find me later, and we can discuss that.
Okay, and I pick the second question, and then we will go for lunch, okay? So the second one is, have you been testing, evaluating?
Simple answer, no. This is the first time I hear about this, so I will definitely check it out. I'm sorry, I don't know that.
So Ondra will stay here for a bit, right?
Okay, sure,
so,
no problem.
So you can ask your questions later, Martin, Tomáš, and the other anonymous guys here. So thank you again, Ondra, for your speech.
Yeah, thank you for your attention.